Hello again. Okay, so now we're going to go over line graphs. And if I can get this camera, sorry. Okay, these are the same kind of, just like a bar graph, a line graph just shows you data, but you have to learn how to read it to get the information that you need. So remember that this bottom piece is the x-axis and it's labeled on this one. And then the side is the y-axis. And people always say, when are you ever going to use algebra? You use algebra a lot more than you think, because this is still basic algebra, is knowing how to read these things. All right, so it says Caitlin's family has kept track of her height. Below is a line graph showing how her height has changed as she aged. Use the graph to answer the questions. So it says, how tall was Caitlin when she was 4 years old? So you have to go to the age. So there's 4, and it's hard to see the lines on my paper, but here's 4 years. And if we follow it up, I'll kind of do like a little dash line up. Just keep going until you hit the line, which is right here. If we follow it over to the height, or over to the y-axis, we find that Caitlin was 40 inches tall when she was 4. So 40 inches tall. And that's it. So just go through the questions and look at the data and see if you can answer the questions. So number 2, how much had Caitlin grown from the time she was born to 6 years old? So here's birth. And then they're 6 years old. So how much from here? Let me do another color. From here to here, or from, excuse me, you don't go backwards. From birth to 6 years, we always read graphs to left to right. Okay. So from birth to 6 years, how high did she grow? Now, this is another one we got to be careful because it starts at 0, and then there's a little dash right here, or a dash line, and this is 5. So you can fill it in if you need to. 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So that kind of helps because at birth, she was 15 inches, and then she grew to 45 inches. So what's the difference between 45 and 15? So 45 minus 15, you always take the big number, subtract by the small number to get the difference. And that's what number 2, that's what your answer will be. How old was Caitlin when she was 30 inches tall? So here's 30. Trace that dotted line until you hit the line graph and see how tall she was. How tall might Caitlin be when she is 10 years old? So this is going to be an estimate. What's the best answer to give? So here's 6 years, here's 8 years. Let's say right here is 10 years. If you look at the bar graph, or if you look at the y-axis, it goes to 60. And it could go a little higher. You could add maybe like 65 up here, but just do a good estimate. Do you think she would grow all the way to 85 inches between 8 years and 10 years? Her shoe's kind of in the way, but we'll pretend that that's like a little dot. If you follow it up, where do you think it's going to land? Would she be at 50 inches? Would she be at 55 inches? Or would she be at 65 inches? Just do your best guess. Using the information that you've already been given, what do you think, how tall do you think she would be? Number 5, about how tall might Caitlin have been when she was 5 years old? So here's 4 years. And it's hard to see on my paper, but here's 5 years. So you can just add that in and then just follow it up. Put a little dot right there and see. This is another kind of, what would the best answer be? Using the information that you're given over here. So how about how tall might Caitlin have been when she was 5 years old? So if you follow it up and go over to the left, just do your best guess or best answer using the data that you're given, I should say. Okay, so that's that line graph. We also have a reading a line graph. And this one has a lot of information. Just know that this is going by twos. So we go from 0 to 2, 4, 6. So if you need to, where there's no number, you can write it in if you need to. You can say 1, 2, 3, 4, 5, and just follow it all the way up. That way you have all that information there to help you answer the questions. Again, they label x-axis and they label the y-axis. So what was the air temperature at noon on Wednesday? And noon is 12 p.m. So at 12 p.m., if I follow it up, it's right there. And then you can follow it over here, and it's at 19. So it was 19 degrees Celsius. And we write that like this. 19 degrees Celsius at noon on Wednesday. Because there's noon. And these are all on Wednesday, by the way. All these times. This is just one day. So it's kind of the same kind of thing. What was the air temperature at 6 p.m. on Wednesday? So you'd find 6 p.m., follow it up, follow it over, and write it just like you did number 1. Did the air temperature rise or fall between 6 a.m. and 9 a.m.? And this one, you can pretty much look at it and see whether it's rising or falling. Because remember, we read a graph left to right. So is that line going up or is it going down? Is it rising or is it falling? Rising, falling. 4, what is the difference in air temperature between midnight and noon? 12 a.m. is midnight. So what's the difference? That means you're going to do some subtraction. So between midnight and noon. So at midnight, our temperature, if I follow it up to the very beginning of that graph, is right there. And then at noon, we already did that. We said it was 19 degrees Celsius. So what's the difference between 19 and 14? And that's your answer for number 4. Then was it warmer at 9 a.m. or 9 p.m.? So which of those were warmer? At what time, let's see, at what time was the air temperature the warmest? So when was it the hottest part of the day? When did it peak and then start going back down? And what was that time? And then number 7, is this more likely to be a line graph showing air temperatures in Canada or Mexico? And we have to remember that we're talking about Celsius. In the United States, we use Fahrenheit a lot. So if I go over to Google on my computer and I say Celsius versus Fahrenheit or degrees, you can find a conversion chart. Celsius to Fahrenheit. And sometimes you can even type it in. So if it's 19 degrees Celsius, whoops. Get it typed in here. This equals 66.2 degrees Fahrenheit. So when we talk about here in Texas, we wouldn't say it's 19 degrees Celsius. We would say it's 66 degrees outside. Celsius is more used in like Europe. They use that a lot. But here in the United States, we decided to use Fahrenheit. So when we go back here, we know that 19 degrees over here is 66 degrees Fahrenheit. This graph really only goes up to 22 degrees Fahrenheit. And that's actually 71 degrees Fahrenheit. So again, this is what we're used to saying. This goes from, let's see, and then I forgot what zero. Zero is, I think, is 32. Let me type it in. Yeah, 0 is 30. This is like winter time in Texas. That's freezing. So this is temperatures in Celsius, but you can get a conversion. So if this ranges from 32 degrees to 71 degrees, do you think we're in Canada or are we in Mexico? Which one is milder, I guess? Remember, Canada, you're in the mountains. It's snowing a lot of the year. Mexico, we can go to the beach. It's a lot like Texas in the upper part of Mexico. So just kind of think about that. This is going to be your best estimate. All right, so that's line graphs. This next video that I'll do will be pictograph.